So welcome to the next chapter of the Erlang course. What I'm going to talk about in this is about how errors are handled in concurrent processes. We've got three parts to the chapter. We're going to talk about the basics of process error handling in the first part. In the second part, we're going to look at how client-server models are, how client-server systems are modeled in Erlang. Look at a particular example. And then in the final section, we look at how to take that example and using the principles of error handling that we found out about in the first part, how to make that system robust. Okay, so let's start by looking at the idea of links. The BIF link that takes a single argument creates what's called a link between two processes. The process that calls the BIF and the process whose PID is passed in as argument. So for example, in the picture you see there, we call link with argument PID of B inside the process PID of A, and that's created a bidirectional link between the two. Now often what happens is that you perform a link at the same time as performing a spawn. And so a typical pattern is to spawn and then to link. There is a potential problem there in that other things in the system could change between calling spawn and link. For instance, a process could be descheduled. So in order to perform the spawn and link atomically as a single action, there is a BIF spawn link. And that will have the same effect, but it will make sure that either both of them happen or neither happens. So we tend to see programs that begin with a spawn link. What's the purpose of a link? Well, what happens, we want to build a system where we control termination of processes. So what we do is a link causes the termination of one process to be reflected in the termination of other processes. When a process terminates, an exit signal is sent from that process to every other process to which it's linked. And the process receiving that signal will exit, and it will itself propagate a new exit message to all the processes to which it is linked. So transitively, when there's been an abnormal termination of a process in one place in the system, it will travel across all the links in the system, terminating the processes which are linked. So that's the way exit signals work by default. But we'll see there are other mechanisms that can halt that behavior. But the picture here shows you that transitive propagation. Termination of process A sends an exit signal to process B, and that in turn terminates B, which sends an exit signal to process C. So all three processes finish up terminating. Now, we can reverse that behavior. We can change that behavior, and the process can execute the BIF called process flag, which changes a number of flags which govern a process's behavior. But in this case, we call it with the atom trap exit as first argument and the Boolean true as second. And that means that the process executing that BIF will now be trapping exits. And instead of these exit signals causing the process to terminate, what will happen is that those exit signals are converted into messages of a format with the exit atom at the beginning, and then followed by a PID and a reason. The PID being the originating process, the process that sent the signal, and the reason being whatever reason the termination has happened. And these will go into the process mailbox. So in this example, the process on the right, if it's trapping exits, will receive a message of the form exit, second argument A, the PID of the process that's exited, and the third argument being the reason. And most importantly, this stops the propagation of exits through the system. So if you trap an exit signal, it doesn't propagate any further than the process which trapped it. So what we'll see in the earlier example, if we now see A sends an exit signal to B, B traps it, and so, so the signal that would previously have propagated from B to C doesn't, and so what we see is that A has terminated abnormally, but B and C are still executing normally. B has now got a message with the atom exit and A and reason in the message, but in the message. But apart from that, it will continue to exit as normal. So B can handle that as it wishes. So just to remind you of the terminology we've established, a link is a bidirectional propagation path for exit signals set up between processes. So recall we said that typically what happens is when we spawn a process, the spawning process links to the spawn process, but this is bidirectional, so if either of those dies, the other one will be killed. And the mechanism for that process termination is this exit signal, which is transmitted by process on exit. And that contains information about the precise reason for the process having terminated. And finally, we've seen the option of trapping an error when a process is going to handle exit signals rather than simply be terminated by them. And they're put into the mailbox in exactly the same way as other messages. Just to remind you of the functions we've talked about, the link function sets up a link between the calling process and the PID, which is its argument. It's also possible to remove a link using the unlink function. Spawn link combines the operation of spawn and link into a single atomic function, and it's the process flag function called with the arguments trap exit and then true or false will switch on or off trapping exits. It's also possible for a user to program in an abnormal termination using the exit BIF with a single argument. If we call exit with the reason as the argument in a process, that process will terminate abnormally, and so that will cause a message to be all the processes to which it's linked, typical exit message with its PID and the reason, which was the reason passed into the BIF as the reason for termination. It's also possible to cause another process to terminate. So if we call the two-argument version of exit with a PID and a reason, that causes the process with that particular PID to terminate abnormally with the reason being the reason we've passed in. So we're able to programmatically create those exits. So we can do that if we're wishing to close a number of programs down. We can do that by choice. Now, we need to be very clear about how exit messages are propagated in different circumstances. The basic message is that when a process terminates, it sends an exit signal to the processes in its link set. Now, an exit signal can be normal, and that will be when a process simply comes to the end of the code it's executing. Or it can be non-normal, and those are the non-normal or abnormal, and those are the things we've been talking about earlier in this session, where we've created either through calling exit or for some other reason a process has terminated abnormally. If a process is not trapping exit signals, then it will die if it receives a non-normal exit signal. We've seen that. That's how exits get transitively propagated through a system. A normal exit signal is simply ignored. We don't. We see it, but it doesn't go into the mailbox. It's simply ignored. If a process is trapping exits, then all incoming exit signals get turned into messages that are handled in a receive statement. So those include not only the non-normal terminations, but the normal terminations as well. Now there is one exception to this, and that is when the reason for termination is kill, a process is terminated unconditionally, whether or not it is trapping exits. So having a reason of kill overrides setting the trap exit flag to true. Now just to be clear about that, here's a table which summarizes those 6 different conditions. Is a program trapping exits or not? Is the termination message a normal one? Is it a kill, or is it any other? And you can see there that the kill message, irrespective of trapping exits or not, results in the process being terminated. And that will propagate transitively through a system. So that's a way of bringing a whole system down. Normal termination messages are, when exits are not being trapped, are simply have no effect. But they do, if a system is trapping exits, it will receive a message in its inbox, both for normal terminations and for abnormal terminations. And in the case that exits are not being trapped, what will happen is that the process will terminate with the reason that it received from the exit message. So I think that has covered how we set up links between processes so that errors are propagated through process networks, and we can see in particular exit signals can be transmitted or not according to the various settings of the trap exit flag and the particular reason that the termination has happened. And we've also revised some of the definitions we've made in this section. So I'm just going to have a pause here, and what we're going to do next is talk about client-server models.